Good afternoon. Our subject is manufacturing processes 2. Now, today we are going to start the fourth module. Is a new module, the new topic, general purpose machine tools. Till last lecture we continued on machining and manufacturing. Today we shall start with the general purpose machine tools. The first lecture under this module will be the kinematic system of center lathe and their operations. So, what are the contents of the lecture today? These are, this lecture will enable the students name the general purpose machine tools of common use, classify the different types of lathes, illustrate the kinematic system of center lathe and explain its method of working, and last and fourth, state the different machining operations that are usually done in center lathes. So, today our topic is center lathe amongst the conventional or general purpose machine tools. Onward we shall cover other kinds of machine tools like milling machines, shaping machines and so on. Now, what are the general purpose machine tools? General purpose machine tools are those which are commonly used and widely used in all sorts of machine manufacturing shops or machine shops. The common machine tools which were introduced or developed long back and are still used in small, medium and heavy industries. Lathes. Lathes are used to produce cylindrical jobs, internal cylindrical surface and external cylindrical surface, rod like. Drilling machine, in which holes, cylindrical holes are originated or sometimes existing hole is enlarged. This is a small machine, not that very big, some holes are made. Shaping machines. Shaping machine is a primitive machine which produces flat surfaces, and the flat surface can be horizontal, vertical, inclined like that, but these shaping machines are becoming gradually obsolete and less used. Planing machines also produce the flat surfaces like shaping machines, but planing machines are meant for big jobs, large size of workpieces. Slotting machine. Slotting machine is basically a vertical shaping machine where the cutting tool reciprocates vertically and it makes internal surfaces, say holes or slots or keyway in holes and so on. These slotting machines are also not very widely used for batch or mass production. Only for repair and maintenance work slotting machines are often used in small scale industries. Milling machines. Yes, milling machines are widely used. Milling machines are generally used for making flat surfaces. Now, vertical, horizontal, inclined flat surfaces resulting say grooves, slots, sometimes they are used for parting a piece into two parts. Milling machines are also used for making some form type of machining like say cutting the teeth of gear. Sometimes threads are also cut in milling machines. Worm wheel or the teeth of worm wheel gears are also cut sometime in milling machine if it is a small production. Boring machines are similar to drilling machines. Boring machine can be vertical type like drilling machine which are normally smaller size, but precision, and horizontal boring machines are very large size for large jobs. Boring machines are normally used for enlarging an existing hole or making a hole accurately in dimension and finish. Hobbing machines. Hobbing machines is a machine for mass production of gear teeth in cutters, say external gears, teeth of external gears can be cut in large quantity, very fast rate by hobbing machine, by generation method. Gear shaping machine is another gear teeth cutting machine, where the teeth of both external gear and internal gears can be cut. Beside that, the teeth of spline shafts, internal external, can also be cut in gear shaping machine. This is slightly less productive than hobbing, but produces better quality. Broaching machines are really is a cutting tool which is used for making flat surface, or other than flat surface, for making holes or keyways. Sometimes small gears, spline shafts are also manufactured by broaching. The broaching tool is very expensive and the process is very fast, and the quality of the product is also good. Grinding machines, that is a slow process of metal removal, but it is used only for high accuracy and finish, particularly when the work material is very hard, cannot be done by machining. Now, the classification of lathes. Now, before that we should consider the classification of machine tools. Now, if we really someone tries to classify machine tools, there can be 1000 types or at least few hundred types. So, instead let us start one by one. First of all, with a lathe. Now, lathes are the most common and widely used machine tools, most primitive machine tool, and these machine tools are most widely used among all the machine tools and most versatile. So, lathes have been this can be classified in number of ways, in number of respects, according to configuration. Actually, the machine tools like lathe can be classified in different aspects. So, what are the aspects according to which it will be classified? That has to be mentioned. For example, according to configuration, basic shape or standing, horizontal. Most of the lathes are horizontal axis, that is for ergonomic convenience. Whatever be the size, height, the length and power of the lathe, horizontal lathes, the height of the center should be at the waist height of a man of common height, so that he can very comfortably and conveniently work on that. But vertical lathes, now there are few lathes normally big size which are kept vertical. Now, main purpose to it occupies less floor space, but for ergonomic convenience these machines are kept vertical and the chucks are kept under the ground, so that the worker can work conveniently. This occupies less space, and this is used for large swing like boring mill and so on, and so these are not very common. Classification of lathes continued. Now, next is according to purpose of use. What are the purposes of use? Three categories: general purpose, single purpose and special purpose. What is general purpose? Which is most versatile and widely used. This is very versatile for wide ranges of material, jobs of different material, different size of jobs, different shape of jobs can be machined. Then various types of machining operations can be done. For example, central lathes. These central lathes are so versatile, these are called mother machine. It is very most versatile, but this is used for general purpose work. Any kind of work on any type of job will be done in this process, but this process is generally manually done. Single purpose. In single purpose, from the name it understood that only one type of operation, maybe occasionally maximum two operations, like say turning and facing, or only facing, or facing and chamfering, or turning and grooving. So, only one or maximum two types of operations will be done on different job material and job size within a limit. For example, facing lathe. The facing lathe, here the chucks are very big, where disc type jobs are faced, on the facing operation is done. So, jobs are of large diameter, but short length. Roll turning lathes, where the rollers of the rolling mills are only finished by turning, and maybe some grooving and chamfering work can be additionally done, but basically these lathes are meant for turning the rollers of rolling machines. Similarly, say copying lathe can be one single purpose machine, and other machines, say now special purpose machine tools, where these are for a special type of job. A particular type of job will be machined over a long period repeatedly. A definite number and type of operations, say 6 or 7 operations of a definite type, say few like drilling, boring, thread cutting and milling. Operations are done repeatedly, same work, same set of work will be done, machining operations will be done repeatedly over a long period, maybe months after months or years, on a particular type of blank. For example, gear blank machining lathe, where the blanks of gears, maybe spar gear or bevel gear, will be machined over a long period. Another example, say the sewing machine, the body of the sewing machine, it needs some machining operations like drilling, threading, boring, facing at different locations, and this work, the set of machining work will be done by the same set of tools over a long period. For that, a particular type of machine tool will be utilized, that is dedicated, which cannot be used for other kind of job. What is the next classification criteria? According to size and capacity. Size, which is visible, and capacity is measured in terms of power, depth of cut, cutting velocity, feed and so on. Small category, there is no really hard and fast line of demarcation between small, medium, large or micro, but generally we call it small, medium, large or very large, mini or micro lathes. Now, small lathes, they are also called light duty lathes, where depth of cut, speed, feed etc. less, and the power consumption will be also less powered, with around maximum 2.2 kilowatt, not more than that. Small and easily machinable jobs. So, here the jobs will be of small size, commensurate to the size of the lathe and power availability, and here the cutting force should not be very high. So, material should not be very exotic type, which produces or difficult to machine. Medium size, when you call it medium size, the power will be within 2.2 kilowatt to 11 kilowatt. Most of the central lathes, those are used in industry, are of this category, medium size, and these are most common obviously. Then large, heavy duty. Now, the heavy duty lathes, that can be even highly powerful, maybe up to 120 kilowatt, and it will be very rigid and high speed machine tools. They are not very regularly used, these are used for special applications. Mini or micro lathes, this mini lathe like switch type automatic lathe came into being long back, but micro CNC lathes have come up very recently for making very small parts of different systems in small jobs. So, it is said that tiny lathes, these are very tiny small lathe, tabletop, mounted on the table, maybe 6 inches long or 4 inches long, even smaller, used for precision machining of very small jobs of easily machinable material, that is soft material, which are not very difficult like carbides or high alloy steels like that. Now, very small jobs. Now, for example, the components of the wristwatch, suppose. Now, wristwatch is a very small device. Now, it has got plenty of mechanical systems like pins, gears, shafts, hubs, which have to be machined. All right. So, this lathe should be very small, and another set of lathe called CNC lathe, which will be computerized, those are also used for making the small parts of mini robots or mini machines. The robot size or the machine size can be, say, 1 centimeter cube, and it may have 100 parts. All the small parts will be machined in this micro lathe, which are it's numerical control and computerized. Now, according to degree of automation, now we know what is the purpose of automation. Automation is a system or a device or a mechanism that enables very quick production, easy production with huge amount of jobs with consistently high accuracy. So, this is the purpose of automation, get the work done quickly, accurately and consistently without human intervention or with minimum human intervention. So, this is very economic process for mass production. Now, the machines like lathes are also categorized with respect to the degree of automation. Many lathes are automated, mechanized, non-automatic, semi-automatic and automatic. Now, how are they classified? Non-automatic. Now, you know that in machining operation, say for turning a rod which has to be turned in a lathe. Okay. Now, before we machine or remove the material, lot of preparatory work has to be done. The job has to be mounted on a lathe, the cutting tool has to be mounted on a lathe, speed, feed, depth of cut have to be adjusted, cutting fluid has to be put off and on, then motor has to be off and on. All these preparatory work are not directly connected with the chip formation, but these are essential, you cannot avoid, and these are called inevitable operations. These operations apparently non-productive are called handling operations, and another set of operations called processing operations, which are directly associated with chip removal, like say facing, turning, drilling, boring, finishing, parting, like that. Now, whether a machine tool will be called automatic or non-automatic, or the degree of automation will be decided by to what extent the handling operations are done automatically. It does not depend upon what extent this processing operations are done. It may be say all the processing operations are done automatically, but all the handling operations are done manually, then the machine will be called non-automatic. So, the degree of automation will be decided by to what extent the handling operations are done in a mechanized way. Now, come to the definitions. Non-automatic, all the handling operations are done manually irrespective of these processing operations. For example, central lathes. Semi-automatic, about half the handling operations are mechanized. There is no mention about processing operations, not necessary. When around 50% of the handling operations are done automatically or in a mechanized fashion, then this machine will be called, this lathe will be called semi-automatic. For example, capstan lathe, turret lathe, relieving lathe, then copying lathe, these are all semi-automatic lathes. Now, automatic, you understand that it will be called automatic only when all the handling operations or almost all the handling operations and obviously the processing operations. When all the handling operations are automated, processing operations have to be automated, there is no way out. So, almost all the handling operations and obviously the processing operations are done automatically, then this kind of lathe or any machine tool will be called automatic. For example, single spindle automatic, Swiss type automatic lathe, automatic cutting off lathe, like this. Now, the characteristics of these machines are that they are very compact, very complex in shape, in design, and operation is very simple, just push button type. Maintenance is difficult if there is any fault, and these machines are expensive. Advantage, these machines work very fast, production rate is very high, and the quality is also good and maintained consistently over a long period, but these are costly. Now, according to type of automation, previously we observed according to degree of automation, okay, degree of automation. Now, you see according to the type of automation. Now, the kind of automation we are familiar with till 1965 are all fixed automation. They are called fixed automation. These are very conventional, often called hard automation. Why these are called hard automation or fixed automation? Because this automation is achieved by incorporating lot of systems, additional devices or systems. Those can be mechanical device, electronic device, electrical device, electromechanical device, hydraulic device, computers, and all these things. But when all these components are mechanical type, hardware type, then these are called fixed automation or hard automation, because if there be any change in the job or the product, then lot of changes have to be incorporated into the machine. Lot of components have to be replaced, thrown away, new components have to be designed and brought in. So, the change over cost from one product to another will be tremendous, a very big amount, and is very rigid. So, the changing to for a new product will be very difficult, very task. Now, example, single spindle automatic lathe, Swiss type automatic lathe, these were invented maybe about 150 years back. So, these are all hard automation or fixed automation. So, these are all driven by mechanical devices. Another category has recently come up, targeting batch production. Fixed automation is very good, economically applicable for mass production or huge production, because the initial cost is very high, changeover cost is very high. But the present trend and future trend is batch production instead of mass production. So, when there is a batch production, the product's size, shape or category changes rapidly or frequently. So, the machine should be capable to cope up with the changeover of the job from one design to another, one shape to another, one dimension to another. Okay. So, the flexible automation is such which can easily cope up with the change. This is very modern and suitable for batch production for low changeover cost. Yes, changeover cost is very low, because whenever the job changes, only the program in the computer has to be changed. So, it does not take much time, it can be done very quickly, easily and inexpensively or low cost. Example, these are modern machine tools: CNC, computer numerical control lathes, turning centers, DNC, FMS, CIM, computer integrated manufacturing system. These are all example of flexible automation, which maintain the advantage is it is very flexible, very quickly, easily and economically change from one product to another with simple programs, and these are very accurate also, maintain accuracy. Maintenance is simpler, but the problem is it is suitable for batch production, not for mass production, and the total cost is really high compared to hard automation, if not more. Now, the classification of lathes according to the job configuration. Now, what kind of job, what kind of configuration of the job the lathe handles, that is another category or aspect of classification of machine tools. Normally, here this kind of classification is appropriate for automatic machine tools, automatic lathes. Say one class of lathe, automatic lathe, they handle bar type job, say rod like, slender rod like slender blank being held in the collet, and jobs are made one by one and cut to size and dropped into the bin. Then this rod is fed again for the next job to be done. Chucking type that deals with disc type job normally, and these disc type jobs, say you have to manufacture these the blanks of the gears, pulleys, shafts, rims, etc. Not shafts, pulleys, gears, clutch, like that, disc type. These are held in chucks. There can be one chuck or there can be number of chucks. So, these are bar type is the most common, that is switch type automatic lathe, single spindle automatic lathe, multi spindle lathe, bar type, these are very common. Chucking type is less common. Housing type. Now, sometimes the jobs are very complex, just like a housing or box like of irregular size, shape and all these things, which cannot be held either in a collet or in a chuck, all right, and they are mounted on large faceplate, which has got number of slots radially and in a tangential, and this faceplate is mounted on the lathe spindle, and on this faceplate these odd shaped jobs are fixed by clamping, and this is not very common, it is only for few occasions and complex shaped jobs. Now, the classification of lathes according to the precision or process capability. Process capability, actually machine tools are assessed in terms of productivity, that is rate of production, and process capability, how accurate, how it can maintain accuracy of the product, the ability to produce and maintain accuracy. According to that, lathes are categorized in two groups. One which are ordinary, called common, ordinary. Most of the lathes are ordinary, which is not that precision, and dimensional accuracy will be vary from 10 to 50 micron, and this is a very common. Precision lathes are occasional, these are very special and very expensive, and only when it is required it is used. These are characterized by capable to provide high dimensional accuracy and good surface finish, and these are costly. Only when it is required it is used, so that the job can be finished to complete dimension and finish without grinding. Now, the classification of lathes according to number of spindles. Now, in our whole body you see there is only one head. So, one head thinks and the whole body does the work. Now, suppose if we have two more hands on the back side. So, from the front, from two hands on the front side we can do some work, and two hands on the back side we can do some more work. So, the productivity can be improved. So, this is just a guessing or an analogy, but in machine tools sometimes the more number of spindles can be provided anyway, but most of the lathes are single spindle. Single spindle lathes, most of the lathes are of this type, where there is only one machine, one spindle, and in the one spindle one job is machined at a time until it is finished. In multi-spindle lathe, where the machine tool is quite large and powerful, and a job to be produced in huge quantity, a very large number over months or say years, and a job requires very small number of operations, few operations, and the jobs are simple, jobs are small, but to be produced in huge quantity. Then for such repetitive type of work of limited number of operations and all these things, here instead of one spindle, the machine can be provided with more than 1, 2, 4, 6 or maximum 8 spindles can be provided, and then the productivity will be proportionally increased, not exactly proportionally, but definitely it will increase with the number of spindles. Now example, these are used for fast production, rapid production of large volume of jobs of simple shape and small size and requiring small number of machining operations. For example, say the bearing races. Say let me draw a bearing, a ball bearing. This is the center and this is the balls, and this is the inner race in which the job is fitted. Okay. This is the job or shaft, this is the shaft in which on which this bearing is fitted. Now here this is the inner race and this is the outer race. Okay. Now let me draw the say inner race. What is shape of the inner race? Like this. Now here this is the form tool by which this particular form will be machined. Similarly, this form will be machined by another form tool. So these are the form tools, okay, and just one form tool will produce this. So you start with a small ring or a rod, then this part will be part of, and then this particular form will be produced by a form tool. So this kind of bearings, inner race and outer race, are produced in huge quantity very rapidly by multi-spindle lathes. This is one example. There can be large, several more other applications of multi-spindle lathes. Now come to the next topic, that is next article, kinematic system of center lathe. So today we are discussing center lathe only, all right, and the kinematic diagram in detail, because this center lathe, as I told you, is the most common type and widely used lathe, and if one understands the kinematic system or kinematic arrangement of this machine tool, then he can learn easily the kinematic system of other machine tools. All right. Now let me tell you what are the configuration, the basic part into this. Kinematic system means the arrangement or the system of the mechanisms or the chain of structure of mechanisms which enable providing motions to the job and the tool. So this kinematic system deals with transmission and transformation of motion at the cutting tool and job. Sorry. So this is the workpiece. So this is the job which is mounted in between the chuck and the tailstock center. This is the cutting tool. This is the cutting tool that is mounted on the compound slide, and then what the main. So first of all you identify where is the job and where is the tool and the relative position. So first you identify the job is a rod like which has to be finished to a particular diameter, and this is held in a chuck on one side, and tailstock is a support, and there is a cutting tool, and the cutting tool will travel in this direction, that is called feed motion, and the job will rotate like this. So, this is called cutting motion, and this is the feed motion which you learned in my previous earlier lectures. Now, what are the major parts? This is the lathe which has got the headstock. This is called headstock, which possesses the speed gearbox inside, comprising of large number of gears and shafts. Then there is a tailstock for supporting the jobs as well as for mounting some cutting tool as and when required, like drills, reamers, etc. These two, headstock and tailstock, are mounted on the lathe bed. It is a rectangular piece, lathe bed, which has got guides at the top, lathe guides, two lathe guides, and this lathe bed is mounted, or the integral part has got two legs. This is one leg and this is another leg. So, these two legs are then integral body are resting on the floor or on the concrete foundation. This is the general configuration, and there is another moving part, a sliding part, this part called carriage. This carriage slides along the lathe bed, and this is carrying the cutting tool to impart the feed motion. Now, let us see what are the motions and how the motions are transmitted, and what are the functions of different parts shown over here, and all the results. First of all, the job has to rotate. So, it has to derive rotation and torque, that is a power, because when this will be machined, the cutting force will be there, the cutting force multiplied by the velocity will produce the power requirement. So, the power and motion, rotation, have to be derived from a source, and this is the motor. It is a single source. So, the power and motion goes from the motor to the job in the form of rotation through the belt pulley system, this belt pulley system. Then it comes through a clutch, a friction clutch for safety, and then a number of gears, cluster gears. Say there are 4 gears here, there are 2 and 4, 3, and this is really, this has been shown for 12 speed gearbox. You know that in lathe or say other machines like drilling, boring, number of spindle speeds are required for different type, for machining comfortably, different type of work material, different type of tool material, different type of operations, different size of job or tool, and different finish or say rough surface. So, we need number of spindle speeds. So, what this is a function, this is called the speed gearbox, comprising of number of gears called cluster gears within the headstock. This will split the speed coming from the motor into number of spindle speeds from low speed, say high speed and medium speed, like that. So, this job can be rotated any one of the 12 or 18 speeds available. Now, this cluster gears has got, say this is a stage. So, this is called cluster, and these are called fixed gears. So, by shifting this gear cluster, we can get 3 speeds multiplied by 2, multiplied by 2. So, 3 into 2 into 2. So, there may be 12 speeds available. Now, this is the tailstock, which this is the center, tailstock center, which can be static or which can be revolving, and this gives the support. Sometimes the cutting tools like drills or reamers can also be mounted here, and this will be moved gradually to get the work done in the workpiece. Now, then this is the saddle or carriage. This is a cutting tool which travels in the direction. Now, the feed, the movement of the tool is called the feed. It can be longitudinal feed, that is along the axis of the job, along the axis of the job. So, the tool will move, that is called longitudinal feed or usual feed. Another feed will be perpendicular to job, that is in this direction, radial feed or cross feed. Now, this cutting tool is mounted on the tool post. The tool post is mounted on the compound slide. The compound slide can be travelled by a screw manually. By operating the screw manually, this slide can be moved forward and backward. So, you can give the feed manually. Then this compound slide is resting on the cross slide. This is the cross slide. The cross slide. Now, this cross slide has got dovetail guides. So, it is resting on another plate here. This is another plate. On this plate, this cross slide moves radially with the help of a screw and nut, and this is the screw on which a gear is mounted. So, when you operate this screw, then this cross slide moves forward and backward radially towards and away from the workpiece. for cutting, for facing, grooving, for similar work, this cross feed is needed. And then this compound slide is mounted on the cross slide. Cross slide is mounted on a plate which it travels on the lathe bed to and fro, and this is fixed with, this is called saddle. So this part is called saddle. This is mounted on, fixed with an apron box, a box like, which hangs in front of the lathe, and that consists lot of mechanisms inside. Okay, and all these things together is called carriage, which moves along with the tool as a whole in the left or right, and sometimes this cross slide can move forward and backward in a direction perpendicular to the axis of the job, that is cross feed. Now, let us see how these movements are accomplished. This cutting tool, so this is the carriage, this where from it gets the motion. It gets the motion, the cutting tool gets the motion from the rotation of the job. So, the job rotates, it is mounted on the spindle, this is called spindle, this is a shaft like, this is a hollow shaft called spindle. From the spindle's back side there is a compound gear, the 1 gear, 2 gear reduction, there another gear and the gear. So, these 4 gears together is called gear quadrant, and they are placed in a cover for safety. Now, this quadrant gear ultimately transmits motion into this shaft, and this is called Norton drive, and this is the tumbler. So, by fixing the gear with any one of these gears on the Norton, we can have say 8 different or 9 even up to 11 different speeds. Now, again that each of the 11 speed will be divided into 4 or 5 speeds by a mechanism called Mender drive. This Mender drive can be of different form, which splits one speed into 4 or 5 numbers. So, if there are 9 gears into the Norton drive and there are 5 steps in the Mender, so ultimately we get 9 into 6, 30, 9 into 4, say 36 speeds into this feed rod. This is called feed rod. This feed rod rotates very slowly. Now, the power is also transmitted from this shaft, from this shaft to this shaft. This is called feed rod, is a rod like, which has got only a long keyway, and this is transmitted to another shaft fixed gears, that is called lead screw. So, this is called, this is the lead screw, okay, which is screwed, lead screw, and on the lead screw there is a nut called half nut, which can be engaged or disengaged. Now, come to this feed rod. The feed rod receives motion from this feed gearbox. This gearbox is called feed gearbox, which has got large number of feeds or speeds, and then on this feed rod there is a worm. This worm rotates and this worm will move along this direction. So, there is a spline or key, long key. This worm is engaged with the worm wheel. So, the shaft rotates. On the same shaft there is a gear on the back side. On the gear there is another gear in mesh. Now, this gear is in mesh with another gear. On the same shaft there is a pinion. This pinion is nothing like a gear, nothing but a gear which is rolls along the rack. So, this is a rack. Okay. These racks are in segments. These rack segments are fitted on this wall or under the bed, just under the bed, and this pinion rolls along this. Rolls means rotate, made to rotate by engagement of the set of gears. So, when this pinion will be rotated and rolled on the surface, this shaft along with the whole body will be moving this way or this way. So, this is how the motion is transmitted from the feed rod, from the feed rod to the pinion, from the pinion it rolls on the rack. So, the entire cutting tool holding this and mounted on the carriage moves in this direction or in this direction, depending upon the direction of rotation of this feed rod. Now, come to the lead screw. Now, the feed rod is engaged for slow feed motion used for turning operation, ordinary turning operation or say radial turning, facing, all kind of work. but when we need cutting precision threads where the feed motion and the cutting motion need to be synchronized and the feed motion should be accurately maintained, then this lead screw is used, which gives the positive drive. Now, the lead screw, before that let me tell you how we get automatic cross feed. Now, this gear is in mesh with this gear, but this shaft of this gear is mounted on a lever. So, by swinging this lever we can engage this gear with this gear or with that gear. This is the gear which is mounted on the lead screw of the cross feed drive. So, when this gear will be rotated, this cross slide will travel perpendicular to the axis of the job, giving what is called cross feed. Now, this can be automated, and here there will be one friction touch to engage. Otherwise, this wheel can be rotated manually, or this also can be rotated manually to give manual feed, but which is not very common practice. Now, come to the thread cutting. This is a lead screw. There are two nuts. On the lead screw there are two nut segments, all right, they are threaded. So, when these two are brought closer, then they will grip onto the threads of the lead screw. So, the rotation of the lead screw will be transmitted to this nut, combined nut, and then the combined nut are the parts of this entire carriage. So, when the nut will travel along this screw, this entire carriage will also move, but this is the first motion required for thread cutting. But arrangement is made such that both this feed, ordinary feed, and this lead screw cannot be engaged simultaneously, either this or that. So, this foolproof arrangement has to be there to save the machine from disaster, that is called foolproof arrangement. And as I told you that, so the cutting tools can also be mounted here. Let us come to the machining operations that can be done in center lathes. As I told you that center lathe is a very versatile machine tool. Amongst lathes also, the center lathe is the most versatile in the sense that a large number of operations can be performed in center lathes over different size or diameter and length of the workpiece and of different material. So, the most versatile and huge kind of operations can be done. Now, we can see what are those operations which can be performed in center lathe. Generally, these are the operations which I am now telling are done. For example, the centering. First is facing. What is facing? It was told in my previous lectures. Now, I am showing you the facing. Suppose there is a rod. This is a rod. This is a rod. This surface is irregular. I want to finish this surface by removing this material. How this will be done? So, we shall put a cutting tool in this fashion of this type, and this cutting tool will be moved gradually in this direction radially, okay, and the jaw will be rotated as usual. So, then how this will be done? So, this was the intermediate position, this is the rod, and this is the cutting tool which has already got into that, and certain amount of material are yet to be removed. So, this amount of material has already been removed. Now, it moves further and this material will be also removed. So, this is called facing. Then comes say centering. Centering means making a hole. Suppose this is a rod end. This has to be supported in a tailstock. Before that, a hole has to be made like this. A hole has to be made like this, so that the center, a center can be fitted here, the tailstock center. This is called centering. This centering is done by a drill called center drill. This is one operation. Next comes rough and finish turning. Turning, this is most common word. So, this is the rod and so this is the cutting tool, okay, and this is the workpiece which is subjected to rotation. It rotates and the tool moves in this direction, it is called feed motion, and this is the material which is going to be removed, and this is the finished surface. This is the finished surface. Now, this is called rough turning as well as finished turning. Rough turning means, you know, the surface, the dimension will not that be accurate and surface will be rough, but when we need finishing we just take care of the speed and feed and the tool shape, especially round nose tool, and we do it by finishing. Then chamfering and chamfering. What is chamfering? Chamfering means, suppose this is the rod, this is the rod end, we want to make it like this. This part will be removed. So, this is called chamfering. Then what is called shouldering? Shouldering means here is one surface we want to make step. So, this end, this kind of step is called shouldering, and that is done by cutting tool like this, which will move in this direction. Grooving. What is grooving? Here is a job rod. Now, we want to make a groove by removing this material. So, this is grooving. Similarly, recessing kind of work can be done. Next is another set of operation called drilling, axial drilling and reaming. So, here the drill is fitted into the tailstock and the reamer for finishing is also held in the tailstock quill, and the tailstock is gradually moved. This is not very common practice. This is for, you know, repair a small lot of work, small few pieces. This is not very, you know, mass production type. Next comes taper turning. The turning taper. What is the taper? You know that this is the rod which has to be tapered. That is, this material has to be removed. This is the length of taper and this is the angle of taper, say alpha. Okay. Now, this type of job are very much required for many purposes, and this taper, cutting taper in lathe is called taper turning. This is called taper turning. This can be done in number of ways in a lathe. What are those methods? By offsetting the tailstock. The tailstock will be slightly shifted radially, and that will enable the production of, you know, small taper angle over a large length. So, longer length but short angle, that can be possible by offsetting the tailstock. By swiveling the compound slide, this is for you know, medium, small to medium angle and medium length. Here the cutting tool will be moved in this direction. So, this tool is mounted on the compound slide and that will be tilted. By tilting manually, you can move in an angle parallel to the job to be produced. Now, using form tool, here the form tools are used for small tapers. For example, say we want to produce a small taper like this, then we can use a tool like this, and the tool will feed in this direction, then this taper will be produced. So, large taper with short length will be produced by, you know, using using form tool. Now, the taper turning attachment is a very good attachment which is time to time attached with the machine tool for turning the taper jobs. This is very versatile, but it has to be attached and purchased separately. Now, this is also possible in some lathes where you can give, here we are turning, suppose this tool is here. So, you give the longitudinal cross feed in this direction and longitudinal feed. So, result of these two will be like this. So, the tool will move simultaneously in this direction to produce taper. So, this can help producing taper jobs. by combining both, but this is a very risky thing, and in very few lathes this is provided, otherwise there is a chance of accident. So, this is a very rare application. Next is boring, machining operations for the boring. Now, boring is an operation, internal turning operation, which is used for producing internal surfaces for straight, stepper or stepped holes, for enlarging some existing hole which is already produced by casting or forging or some other method, and this is boring is also used for finishing work. For finishing work, finishing means to approve high accuracy and surface finish. So, the boring machines are expensive. Forming, several types of forming, both external and internal, are possible. For example, machining the grooves of typical forms of the inner and the outer races of ball bearings, roller bearings, I already explained to you. So, this is forming. Forming, for example, I can give you one example. Say here is a rod with a collar and you want to make it round. So, you take a tool like this and feed in this direction. So, this particular form of the tool will produce this kind of job. This is a forming, this can be external, internal and other ways. Now, machining and the other operations, cutting screw threads, external screw thread, internal screw threads, both are possible. These have been discussed with a lot of illustrations in the previous lectures. The parting, where a rod will be part into two pieces by parting tool, and knurling for making the surface rough for the purpose of handling. This is knurling, and for that purpose a special, suppose here is a handle of an instrument, and for holding purpose this has to be rough for gripping, and this kind of grooves or this rough surface is made by knurling process. Last, beyond those operations, beside these operations which are usually done, some special operations can also be done by mounting special attachments. What is the attachments? A cylindrical grinding. In cylindrical grinding, suppose this is a job and this has to be finished by grinding. So, instead of a turning tool, you use a grinding wheel that will be mounted on a motor. The motor will be mounted on the saddle. So, this will move in this direction and this will rotate. So, this is an attachment. Similarly, thread milling, say threads of long power screws are produced by milling process by milling cutter, but that is driven by a separate motor and mounted on the saddle of a lathe. Thread grinding, the threads are finished by grinding, that is also done by an attachment, and producing profiles by copying. So, some hydraulic copying. So, hydraulic some copying attachment is available in the market, which can be mounted on the lathe saddle or clamped, and then it will be used for copying. Say the job to be produced has to be fixed at the bottom as a template, and the stylus will copy it and reproduce into the tool by hydraulic copying servo system. So, beside that, few more operations can also be done if challenged or if essentially required in lathe. So, lathe is very versatile, and maximum number and type of operations can be done in central lathe, unlike any machine tools. Thank you.